Alrighty, in this video, I want to look at the question of how do we take the derivative of an exponential function in the form y equals a to the power of x. In that format, a is a constant, like 2 or 10, and x is our variable, and this, of course, is an exponential function because the variable x lives in the exponent. So the problem is we don't know how to do this. We don't know how to differentiate this thing. We can't use the power rule because it's not a power function. What I mean by that is that I can't say that this is x times 2 to the power of x minus 1 because it is not a power function. That does not work. So we are stuck trying to do this another way. And the way that I'm going to do this is a little bit sneaky. We're not going to use a limit definition of a derivative. I'm going to explain this to you a different way. And this isn't something that you're going to need to recreate. I just want to explain where this comes from and why it is what it is. So what I want to do is remind you of something. And that something is that if you take e to the power of the natural log of a, which a is still going to be some constant for us now. Let's pretend a is, 4 or 10 or whatever. And if I want to figure out what is e to the natural log of a, I can solve this problem. And actually, if you're in second hour, I think you saw this as a warm-up in class. But we can solve this by putting this into logarithmic form. Currently, it's in exponent form. You've got some base raised to some power, but I can put this into log form by writing log to the base of, or log base e of question mark, that's the old output, which is now the input, of ln of a. And if we remember that the natural log of a is log base e of a, then what I'm doing is I'm comparing log base e of question mark to log base e of a, and obviously question mark and a have to be the same thing. For this equation to be true, a is equal to question mark. So I can go back up here and say that e to the power of the natural log of a is equal to a. It is as if this e and this natural log cancel each other out. So the reason that I'm doing this is because what I'm interested in doing is taking the derivative of a to the power of x, which even though I don't know how to do that, if I can express a as e to some power, that's good news because we've spent all week so far looking at the fact that if my function is e to the power of x, the derivative is itself. So if we can capitalize on that bit of information, that sure would be handy. So that's what we're going to do. I'm going to take the derivative of a to the power of x by writing this as e to the natural log of a, remembering that this is all equal to a to the power of x. So let's try that. So again, just to be clear, I'm taking e to the natural log of a to the power of x. I'm going to take the derivative of this. And this is equivalent to me taking the derivative of a to the power of x based on this explanation. Okay, so here is what I'm going to do. I've got e to the power of the natural log of a to the power of x. So I'm going to take the derivative. I know that the derivative of e to any power is just e to that power. So e to the power of ln of a times x. And now I need to multiply by the derivative of what's inside. So I need to figure out what is the derivative of x times the natural log of a, or the natural log of a times x. Now if we remember that a is a constant, I'm just going to pull this to the side here and put the x out front. If I remember that this is a constant, suddenly this becomes like find the derivative of 2 times x, which is just 2. The derivative of x times the natural log of a is just the natural log of a. And we could do the product rule to prove this to ourselves. We could take the second times the derivative of the first plus the first times the derivative of the second, and the derivative of a constant is 0, so this goes away, leaving us with just ln of a. So all that to say, when I come back here, I'm going to take e to the natural log of a times x times the natural log of a. So we're good. And this is great. We're not going to see it like this, though, because remember that we took this thing, and this little switcheroo allowed us to take this derivative. But what e to the ln of a actually is a. So the way that we're going to see this more often is y prime is equal to a to the power of x times the natural log of a. So in summary, if my function is a to the power of x, the derivative is a to the power of x times the natural log of a. So if we throw a number in there and we say that the function is 7 to the power of x, the derivative is 7 to the power of x times the natural log of, the natural log of 7. But what if we have a number out front, 4 times 2 to the power of x? Remember, PEMDAS says that I can't make this 8 to the power of x. I have to deal with my exponents first. 2 is being raised to the power of x. And then it's being multiplied by 4. So again, this is not the same as 8 to the power of x. So just like anything else that we've dealt with, if we have a constant out front, just leave the constant out front and then differentiate the rest. The derivative of 2 to the power of x would be 2 to the power of x times the natural log of 2.